And I would like to invite our companion, Diogo Cotis. He's our colleague, and he specializes in virtual reality, artificial intelligence. He's also a professor at the Pontifical Catholic University. He is going to coordinate the activities here. He's also going to introduce the keynote lecture, and therefore I pass him the floor. Thank you, Wagner. Thank you, everybody. We're going to move on to the first presentation with our first keynote. I'd like to invite Mr. Charith to the podium. His co-founder, he actually arrived yesterday from Japan so that he could be here with us. So he's co-founder and director of technology at Telexistence, Inc. He's assistant professor at Keio University in Tóquio, Japan. He has a PhD and a master's degree by the Media Design School in Japan. And he has a degree in electronic engineering and telecommunication by the Muratua University in Sri Lanka. So his areas of interest are how robotic can be used to influence our society, focusing on complex activities with the robotic body as an extension of your own body by means of visual, auditory, and tactile senses. And so the title of this lecture is The Future of Telexistence. And recently, Charith received us at the Keio University in Japan. We were really impressed with everything they are developing there in this area of teleexistence, and it involves both robotic and also some web technologies. When I visited this laboratory, I was able to feel what Arthur Clarke said. He said that any technology which is sufficiently advanced cannot be distinguished from magic. So we were able to experience these technologies that are still being developed and have a feeling that the future can be a little bit better. We tried some robots with a remote control. We also had an out-of-body experience where you see yourself outside of your body. This is not magic, it's really technology, but it has been used in research in the areas of neuroscience, psychology, and science universities or neuroscience universities are already using this approach to work with people. It's a vast world, and therefore I'm going to open the floor to Charith. And I would like to thank you very much for having visited us.
Thanks everyone for inviting me for the Ceweb.br conference in Brazil. So it's really a great pleasure to talk to a community close to like internet and web. And because the work that we have been doing is really close and related to the web, so I would think maybe like you would enjoy the talk very much. Okay, so the topic that I would like to discuss is the latest trends of industrial robotics and future of teleexistence. I think most of the people will not know what is teleexistence is, and probably that's what I'm going to introduce in the first few slides as well. Okay, so so you might have seen different kinds of robots in your life or like work, but like those are for consumer robots, industrial robots, and like personal robots and toys. But this is something that you might have not seen. So let me explain. So the person who is in the left side is actually operating the robot on the right side, and he's actually inside this robot, so his all motion is linked. and also not only that, like he sees himself through a mirror, so that like he's like doubtful that am I inside the robot or someone else. So let me continue. So this is not a normal just robotics. It's greatly related to virtual reality. I think most of you here knows about virtual reality, right? So this is a photo from MWC, Mobile World Congress 2016 in Barcelona. So you see, like, with the start from Oculus and HTC, and also the Samsung's Gear VR, like the consumer electronics is like adopting virtual reality since like 2013. So this, like, even though all these people are in the same place, but they are linked to a virtual reality headset, and they are in different world compared to where they are really like sitting. And it is true that the world is like spending a lot of investment and also effort to make the hardware and software of virtual reality into the next level. So as you can see, like we are right now in the end of 2017, there's hardware companies are getting more and more, and once the hardware is done, there will be a lot of virtual reality and augmented reality applications gonna be in the society. And not just virtual reality, this is actually the hype cycle of emerging technologies that was introduced in 2000, which is adopted for 2017. So you can see virtual reality is actually in the slope of enlightenment, which is like it's been peaked this, and now it's in the production state, or like it's being now in the consumer level. So there's more to go, like for example, augmented reality, cognitions, blockchain, the smart robotics is somewhere here, it's just going to the peak, and also like BCI, brain computer interfacing, 4D printing, and so on. So what I would like to say is like, so similar to like virtual reality, all these things, for example, robotics is going to be the next trend of the world, of like how it will change the people's world. So with regard to that, I would like to show, this is the global robotic market, and as in deviation from personal to military, commercial, and industrial robots. So I think you know most of the like personal robotics, which is as toys or something, but it's been gradually growing towards like increasing of like commercial and industrial robotics as well. And this is the Pepper robot, previously from Adelban, from French company, and now it's been taken over from a Japanese company, SoftBank. So this is the first commercial, how to say, mass manufactured robot for like consumer level. And not only that, there's been a lot of commercial robotics being used in like warehouses for asset tracking, outsourced warehouse fulfillment, and so on. So about next is the commercial robotics. Probably you might have seen a lot of these robots in the industrious conveyors, but do you know what are the main key areas that these industrial robots are being used up today? If anyone knows, probably I would like to get an answer. What's the key industry that is being used these industrial robots? Manufacturing in specific, if you... Automobiles, yes. So, by subtracting, one of the main industry is welding for automobiles. So they are just welding, like it's like with a tedious task which is like used to be humans, but now it's being used by robots. And the second major one is painting, it's again automobile. So these been like most of the time, like it is been like automized using the robot technologies, and also there's been a lot of startups, not only just in US or Europe or the other countries, like everywhere, like there's a lot of penetration going on to the startups in robotics. And so let me just introduce like how and if we are to connect the robots through internet, how it is being controlled. So the previous robots that you have been seen through the slides, they are like offline robots, which is not connected to the internet most of the time. It is being like programmed and it is running just a program. So, but in the future, we think that the robots will be connected to the internet, and there's going to be a lot of potentials that humans can be connected to the robots and so on. So even though the robots are connected through internet, it can be probably partial, like artificial intelligence or machine learning technologies can be used into like control the robots. And also it can be, and also it's being used like keyboard control robots and telepresence and teleexistence, which teleexistence I would explain a little bit in the next slide. And a combination of these two, fully automated and remote control, will be a hybrid, which means like a human operated, but also it will be assisted using AI robotics, the latest 3 trends that is being used. When in contrast to like when the robots is being used over the internet. So when you have this kind of trends, what would you expect for the next, let's say, 5 or a decade of time? So the robots will be in the streets, or the robots can be used for like in disaster sites, or you can even go into like a miniature world, which is like you can go into a small tiny robot which lives with insects or something. And also robots is being used for like construction and like heavy machinery applications as well. So the work that I've been doing, which is greatly related to teleexistence, and let me introduce what teleexistence means. It's been proposed by Professor Tachi from University of Tokyo, and it enables a user to bind with a robot and perform tasks very smoothly, similar to like a human working in the same like physical place. So not only just like seeing what the robot sees and hearing what the robot hears, he can also feel what he touches in the remote environment and get a grasp of like how it feels to be like touching that object on your own hands. So let me show you a small video of like this teleexistence. It's been started since 1980, and these are I'm just gonna reduce the, yeah. So this is a brief history of like what has been
Teleexistence
done.
allows a person to experience a real-time sensation of being at a location other than their own, and to interact remotely with real or virtual environments. In 1980, the concept of teleexistence was first proposed
introduced in
by
the
Professor
1980s with a very simple concept which is similar to like telepresence.
It was first published in Japanese in 1982, and subsequently in English.
It is a very simple interface that it's a master-slave robotic system that a human operates a robot over a different location.
Include existence in a virtual environment or existence in a real environment through virtual representation.
So as for the first proof of
in
concept,
1985,
a
method for mobile
tele-vehicle
proposed,
or like a remote control vehicle was used, and this is how the vehicle looks like, and using a joystick for locomotion. But as you can see, like the operator's head is controlled according to the robot's the head. And the first humanoid or single-handed robot was used to see like the biomanipulation, and as you can see, like these like tiny manipulations can be done over distance with the help of a robot.
In 2000, Telexistence in a humanoid
And
biped robot
this
was
is a
achieved by
remote,
developing a
this is a
Telexistence
collaborative
cockpit
work that
under the
was done
Humanoid
with
Robot Project,
bipedal
HRP.
robot, which is
Furthermore,
was
the
like
advantages of
trying
human-like
like is it
motion were
possible
proved.
to like walk on a remote environment
In
with this kind of like
2005, a
remote
mutual
presence
Telexistence
experience.
master-slave system
And
called Telesa
this
2
work
was
is
constructed for the IT
explaining,
World Exposition using
for
retro-reflective
example,
projection
so how
technology,
when a
RPT.
person looks
In addition
the
to
robot
conventional
on the
bidirectional
remote
verbal
environment, he
communication,
looks
simple gestures
who is
such as
operating the
handshakes
robot. So
could be
as
performed.
like using
In
reflective
2010,
material,
a mobile
he can
mutual
see like who is
Telexistence
operating
system
the
called
robot.
Telesa 4 was developed with master-slave
And for example,
manipulation
this like so he
capability.
can see
It was
is
equipped with an
like
immersive
handshaking with the robot,
omnidirectional
but he can
autostereoscopic
see
3D
who is
display
inside
called
the
Twister
robot at
with
the
a
same time.
360-degree field of view.
And
Using Telesa 4, local participants at the
by
event were able
combining-
to view the face and expressions of the remote participants in real time. In 2007,
so this one
Telesa 3
explains
was
like
constructed, which
the
can
smooth
transfer
operation
visual
of like
information
the
in a
motion
more
of
natural
your
and
like
comfortable
head
manner
motion,
by
so
accurately
that like
tracking
you
head
can
motion
not only
reversal
just like
with 6
see using
degrees
a
of
normal
freedom.
camera, but also like you can like move according to
In 2011,
where you want to
Telesa
see like
5
all
was
the point
developed
of
with a
view.
conjunction of 53
And
degrees
by
of freedom
combining
for
all
performing
these
full-body
technologies,
movements. The transmission of haptic sensation
the Telesa
allows
5,
the
which
operator
is
to
the
feel
latest
vertical and
version,
shearing forces
was
exerted on fingertips.
built,
The
for
operator
example,
can
like
freely
you can
independently
see
move the
here
robot's head,
a complete
body,
operation
and
using
hands
both
so that
hands,
there is
both
while
arms,
maintaining
as
the
well
head
as
to
he
arm
can
with
feel the
free
haptic
hands.
sensation
The
when
operator
he
can feel
manipulate
tactile and
the
thermal sensations
remote
when touching the
operations.
remotely. Our future vision is to
So
expand
let me explain how this robot or the teleexistence concept works. So there's a robot on the remote environment and there's a user. And so you get the visuals from the robot's cameras to an HMD on the human. And on return, the entire body motion, for example, arms and hands, as well as the head, the body motion is sent to the robot to operate the robot joints. And according to how he moves his body, head, and arms and hands, the robot moves accordingly. And once he touches on the remote environment, the haptic sensation is feedback to his fingertips, so that like he can feel what sort of like object that he was touching. In precise, I would explain a little bit of haptics in the next few slides. So how it like creates this kind of sensation is like, for example, this is an experiment done to show what happens. So here's the user, and there's a red cylinder here, and this is what he sees actually. And so he's trying to grab or grasp this red cylinder, but actually in front of him in physical, he has a white like fluffy object. So at this moment, like when we ask this person, like what did you see and what you felt, he obviously says it's a combination of these two, which is like a red cylinder with a fluffy softness. But in reality, it's not what he feels and what he touches. So it's a combination of like the virtual reality and the physical object. So what I want to say is like, if you can really blind this person by providing the same like object in the remote environment, so that he can be like augmented to a different perspective. So with teleexistence, like you might know like the body extension, for example. So when you like playing some game, like for example using a racket or baseball bat, like it takes some time to get used to the racket. But the first use, like you won't be able to grab and just hit precisely the ball. But over time, like you can precisely manipulate and like you can hit precisely, which we like on the psychology it calls like your body extension is like extended towards this the racket or the bat, so that like you don't need to think every time, like you can just use it as is a part of your body. So what IntelliExistence also does is actually like it is being extended, but not just few centimeters or something, but it's over internet few kilometers or like a far away distance. So, and this is some of the examples that we have been trying, like so to use like the Japanese chess or like writing calligraphy. So every operation is actually done by a human, which is logged into the robot, so he can precisely know the environment, know what he's like touching, and like he can control precisely. So not only this, so we also did actually an experiment on like how this kind of teleexistence, or in other words, by controlling a robot using a human, how the task or the manipulation efficiency will be increased. So we did I'm not sure if the audience knows what a PIH or a pegging hole experiment, which has been very widely used in robotics. So you have an array of 9 holes, which is very, so the peg is the one you are like putting that the stick. The size is 21.5, and the hole sizes varies from 22 millimeters to 23 millimeters. And the translation distance is between the 2 holes, the distance. So what it was done is, let me play this video. So as you can see, we used, this is only using a robot, but in the real experiment we use just a human to do this task, and also just a fixed robot, which is not so much having degrees of freedom, and we increase the number of degrees of freedom similar to a teleexistence robot. So we compared the time taken to complete this pegging hole and calculated the efficiency. So it's a very common index called like Fitts measurements index, and so I'm not sure if you can see it. So if I explain this graph, this is the measurements index, performance measurement index, and this is the whole numbers, or like the number of tries. So this black line means when this task was done by a human, and this red the line shows when this task was done by a teleexistence robot, and here the 2 graphs shows when this task was done using non-haptics as well as non-teleoperation, which is not synchronized with the human body. So what we found was like when this kind of operation is synchronized with the human body perfectly, the efficiency greatly improves. But of course, the ideal is here. There's a long way to go, but as you can see, like it's like very much improved compared to a normal traditional teleexistence, telepresence applications. So let me show you some of the hand operation. So this is a close-up that is being taken from this telesapphire robot. So you can see like this is in real time, and place the video in like 1:1 speed. So you can see like it follows exactly the same operation. So we are doing some calibration at the beginning of the user's operation, and once the calibration is done, like most of the people can achieve this kind of accuracy when doing tasks. And why I showed this one, because when you do manipulate in remote operations, the hand is the most important thing that it comes to the place, because like if the hand reacts to your same motion, you can do most of the task as you would do physically in that remote operation. And here is a simple explanation about how the haptics. So we have three kind of haptic sensors and actuators: the force, the 2 degrees of freedom force, and thermal, the temperature, whether you feel hot or cold, and also the vibrations or tactile feedback, so that when you touch a rough or smooth surface, that you can distinguish between it's a rough or smooth surface. And this, up to this, it's been done in around until 2012. And then I would like to show you some of the real-world applications that this teleexistence was used. So here's a experiment that we have been doing with a construction company. So as you can see, like this, the backhoe is operated completely remote. There's no human operator. If you see, there's instead of the human operator, there's a robot in there. And so this is, in this experiment, the distance was about 500 meters to 1 kilometers. And as you can see, not only just like moving the robot, but also like he can hop and dig precisely as he was sitting in that deck. So we did several experiments using experience like operators as well as non-experienced operators, and most of them was telling that it's almost like same as like they are sitting, because like they can, you know, move around, see the side mirrors, like the knobs and everything, so like they feel that they are really in that physical location. But to operate and safety, like they can grasp everything as they were in the physical cockpit. And secondly, we did an experiment related to disaster environments. So we built a sort of a multi-crawler robot, and this was operated through a repeater on the different sites. So this was done basically in a volcanic state in Japan. It's still an active volcanic, which is called Unzen. And the operators operate this robot. Sorry, it's so as you can see, this is not a real like disaster environment, but we simulate like this kind of muddy or rough surface, because as you might know, running a robot in a normal like carpet road is very simple compared to like where there's like no roads, no signs. So you need to grasp in real time, so what's happening, whether is it possible to run through this road, whether it will collapse, or like all sort of things. So in order to have this knowledge, it's not just like, how to say, visual, but also like the audio, as well as like the haptic sensation that you would feel when you are really sitting in this robot will really helpful. So it's been operated completely remote, and also, so this is like a sample taking application. So there's a rod that we penetrate to the bottom up to like 3 meters and get samples of like how the how to say, the soil is damaged. So we can get a profile of like whether it's a stiffness changes according to the depth, so that we know like, okay, this is a collapse location, or this is by default the soil was very hard, and so on. So we also did, this is just for a fun application, so we put a camera, 360 camera on a runner in the Tokyo Marathon, which actually ran 42 kilometers. And so this is a close-up of like how it looks like, and we use a gimbal to stabilize. And also, so we real-time, streamed the data through a mobile network and allow the person to run on a treadmill, synchronized with this, the running. So it was very interesting, like most of the runners were saying that like they really can feel they were running together with the other runners, and it was really cheering, and it helps like to get like motivated to run more and more. So we also have some applications of this kind of drones. So you send a drone to the sky, and like you see from the bird's eye view as well. And so at this point, I would like to explain what the current trends, mostly, probably most of like what's DRC, DARPA Robotics Challenge, which was done a few years ago. So there's a lot of robots being made, and there's a lot of artificial intelligence as being used in the robotics, but when an unpredictable task is given, it's really hard for a complete autonomous robot to react to the environment. So that's where a hybrid approach, or like teleexistence or artificial intelligence comes into the next generation. And so recently we started a new company called Telexistence Inc. To commercialize this teleexistence technology. So what our main business opportunities, we are looking into like 3 different tasks. Telepresence, like for example, participating in a conference or in a meeting, like most of like you sometimes go into a business meeting, like spending a lot of hours on a flight, but then comes back. So like these can be like recovered from if you have a real presence robot. And also telework, like you can manipulate in the remote environment or dangerous environments, and use as like security bots, construction as well. And tele-experience, probably like you can have a new experience, for example, in the space or museum, or as like e-commerce, for example, buying like stuff using through a robot kind of thing. So future world created by teleexistence is like creating a comfortable telework environment so people can work no matter what their, for example, disabilities or abilities, can work from a remote environment, and you don't need to like travel so far. So you can like, if you have reach to an internet, so you can just connect to a remote robot and manipulate as you wish. And I would like to show with the increase of the trends of 5G, probably most of you know. So we are right now in the transition of 4G to 5G, and which is like, I think next year we would experience like 4.5G or the LTE-A, which is like the next generation of the 4G. But when it comes to 5G, the speeds and the latency will be drastically reduced compared to 4G, which we are right now facing issues, because in order to operate that kind of robot, we need like real-time video, like with a fair amount of resolution as well as quality. So if we have to like transfer everything over a wireless network, it will be really hard, and there will be latency introduced. So when a latency introduced, what happens is like you don't feel the same fluidness of like operating. So when you want to like move it, it happens like, let's say after like 1 second, then you get really like frustrated, like why, like I want to move, then like it doesn't move according to that speed. So then if it continues for more than like several minutes, like you get dizzy or like sort of like a VR sickness, and then the total like efficiency of like remote operation will be like reduced. Of course, there's a lot of researchers working on like how to operate remote robots through a latency world. So which have like, for example, if we consider like operating on the space robots, there's like several seconds, not just like milliseconds from the Earth to the world. So we can't avoid that sort of like latencies, but so there's ways to like recover this like dizziness or something or over time. But first of all, if we just work in a perfect environment, if we can reduce the latency, the efficiency can be really improved in terms of telework. So we are like, for example, right now testing with 4.5G and 5G networks in order like how, because everyone says like it's really low latency and like very high speed, but we don't know when it connects to a robot like how the performance will be increased and so on. And this is sort of like a cloud platform that we have been building. So the robots will be connected to a cloud, and there's going to be operation managers, and also like the users will be connected to the same cloud, and they can choose like which robot or robots, so they can multiple like choose like how many robots they can control at the same time as well. So a little bit of web or something we use internally, somewhat WebRTC. I think most of you might be familiar. So we are using the data channels and media channels to send the audio and video as well as the motion data to the robot. And this is not just one approach. This is just an approach that we are trying right now. And of course, like there might be different approaches that we can bring up to the cloud, that we can reduce the network between the latency between the robot and the human. And so finally, I would probably like just ask for a note. So because most probably I think most of you might be interested in like what are the problems we are facing in like WebRTC. So several problems that we face right now is like media prioritization, for example. So when it comes to like video data, so we, for teleexistence or remote manipulation, for example, we need to keep a higher frame rate all the time, and at the same time we don't want to reduce, for example, color, but the resolution is not a big issue, for example, but dynamically changing, for example, like adaptive rate control mechanisms might be really frustrating for the user, because like when he moves here and here, if it's two different like frame rates or two different resolutions, he might be really questioned or puzzled. So this, if there's a way that if we can fix these things, that might be really helpful for like operating robots over the network. And also the routing between two locations, of course, once a connection is established, it's static, but for example, if multiple times are being connections are being taken, the routes can be dynamic. So I mean, obviously it's the behavior of the internet, but if some way, if we can minimize the dynamicness, so this can reduce the difference in latencies over time. And also the media to data channel, because we are sending the data or the motion data through the data channel, and it's sometimes hard to have a synchronization between media and the data over time with just like timestamp, because like if the data is lost, like you might lose the whole chunk of data. So we are looking into like different approaches using WebRTC as well as other technologies. So it's actually like open for like all the researchers and everyone. So if you have like good ideas, that would be really grateful. Basically, for the teleexistence business, so this is sort of like the map that we would like to work through for the next couple of years. And then my last slide will be this one. So we will be participating in this Avatar X Prize, which is sponsored by ANA. This is not yet started, but it will start in like next year, somewhere next year. And as for teleexistence, we would like to participate in this for the race for like making an avatar robot to the next generation. And thank you very much.
Hello. Thank you, Charith. Congratulations for your work. Muito interessante ver a internet mudando dessa ideia, né, do princípio.
It's wonderful to see so many changes, data connection, things connections, and now Charith is telling us about web connecting our feelings, our cognition. As Professor Glaser said, we are right in the eye of the hurricane. And if his presentation it's full of novelties and great opportunities. We were lucky enough to visit the lab and to experience some of the researches. We tried two equipments. One of them you would put on the goggles, and we had that out-of-board experience with almost zero latency. And a second experiment of a touch feedback. Two glasses, you would place balls in one of the glasses and someone else, somewhere else, would feel the same impact of the balls. And then you would look at the glasses, where are the balls? And that reminds us the idea of Arthur Clarke. Things, they seem to be so fast and they look like magics. Now let's open the floor to Professor Charith. Please ask your questions in the mic so we can translate to our dear guest. Good morning. Congrats, Professor. Wonderful talk. And it's good to hear that we are heading towards robotics. I work with accessibility for the past 4 years. What about possible controls throughout thinking? I understood that most experiences, they benefit from upper limbs movement, upper limbs motions. Are there any researchers considering that robots would be controlled throughout their minds? I am asking you that question considering some patients that have some sort of degenerative diseases or tetraplegia.
And so exactly. So I would say that using brain-computer interfacing or using the human brain to control the robots is going to be the next level of AI. Of course, there's been a lot of researchers trying using the simplest experiment using like mouse. Like you put some electrodes to the mouse and control using the mouse thinking abilities and stuff. But it might take, I would say, like at least like a few decades in order to implant into humans. But so this is the one that I explain right now is actually like one step behind that one, so that we can actually right now use and see like what are the possibilities. Of course, when the BCI or brain computer interfacing arrives, we can just transition to that sort of technologies so that it will be the same experience that the human feels.
Ok.
Any other questions? Hi, my name is Richard. I work for global TV broadcast. We have some experiments with some drones where we try to turn some characters into robots. I like when you say about the response time almost zero. What do you see in terms of future perspectives, considering the deep learning curve high in a higher level, and resolution, innovation, and all of that? How about WebRTC? Is that strong enough for confidentiality or for reliability?
That's a very good question. So, as I was saying, so we are trying WebRTC as well as other approaches like our own like transmission media. So I cannot say at this moment whether the WebRT is the best solution, but I would really like to say that like the WebRT is built for real-time transmission or like real-time communication. So it has the capabilities of controlling, including controlling robots. So there's set of things that's needed to just add to the WebRTC in order to be used for real-time operation. But if that can be achieved, I think WebRT is a nice solution. So I think probably that answers the question.
Mais uma.
Good morning. First of all, thank you so much for your talk. In game development, especially in animation, we apply a twinning technique. That is, if we lose any type of information between one frame and another one, the computers, they can know exactly what to do to reach one point to another. Would that be a feasible technique to solve latency problems with the telexistence? I mean, if we lose any information in the meantime, will computers be able to rescue that intermediate level?
It's a very good question. So actually, we are trying, probably you might have heard like forward error correction, or which in other words like FEC. So how it works is, for example, you send some parity data. It works same as like, let's say, RAID systems. So you send some more data. When you lose data, you can recover from that. So that is something that we have been trying. It's including, I mean, it doesn't matter like we use WebRTC or non-WebRTC. It's going to be losing data anyway if we send it through the internet. So there's ways to reduce. One way is using, same as you were mentioning, we are sending like more data and to recover data based on the lost packets.
Once again, congratulations for your presentation and for this amazing technology. I have a question regarding the use of robots for external work. In theory, an employee, an operator, could cover several other employees virtually. I mean, a production line or an assembly line, we could have one employee maybe to cover the shift of maybe 10 or 15 other employers in an assembly line. Would it be possible to rule out a huge work shift and eliminate a great number of people?
it's true that I think when the time comes for a robot to be exactly the same efficiency as a human, it's going to take some time. But we need to also think and take care of the thing that the world, the workforce is growing down and down. So, for example, I'm not sure about in Brazil, but in Japan, most of the workers right now, they are struggling into getting into the young crowds, into real intense tasks. So in Japan, for example, they are finding and also using foreign labor in order to get the work done. So we would expect that at some point there's going to be there's not enough labor in the world to support the industries. So that's when probably the robotics or the robot workers might be useful in the future. And for the efficiency, I think over time, using artificial intelligence or machine learning, we can, learn skills from the humans. So it will increase over time, the efficiency. So at some point, I would say it would be equivalent to a human, but it has to have a long time. Yeah.
Okay. Muito obrigado, Charith, pela presença.
That's it for now. Thank you so much, Charith. I hope that you join us again in our next edition due to telepresence, avoiding 24 hours flight.
I think most of the crowd is really a part of web and internet, so I think it's probably a nice place to talk about the future of the web. Yeah, thank you.
Thank you.